Hi there. In this video, I will tell you how to interface a temperature sensor and read temperature from a Raspberry Pi Pico using MicroPython. In order to read temperature from temperature sensors, you need a temperature sensor that is most commonly available. This is a DHT11 sensor. You will also find a more slightly updated variant of it, which is also called as a DHT22 sensor. The difference is very simple. I think the DHT11 sensor will give you temperature readings in 2 digits, which gives you accuracy up to like say 24 degrees or 25 degrees and so on. But then the DHT22, on the other hand, will give you up to decimal precision. So you can get temperature like 24.5 degrees or 26.7 degrees and so on. You will get with decimal precision. So that is the difference between these two sensors. So if you're looking for decimal precision, I think you can go for the DHT22, which is slightly expensive compared to DHT11, which is most commonly available. You also have another more sophisticated sensors, like we have the BME 280 based sensors. You might have BME 280 and BME 380 sensors, like you can see here. This has the header soldered, so this has a small chip here. This contains temperature, humidity, and also altimeter. So I think it also select the atmospheric pressure, I believe. So it's got all the features. And yeah, there are also some more variants of the same chip. I think there's a BME 380 based chip, which you can see right here. This does not have the header soldered. The headers need to be soldered on this particular device in order to use them, right? So you can see the sensors in here. So all of these are different variations of the sensors, right? So you have the BME 280, which has got a small chip here, right? Very small chip, and this one has got a slightly bigger one. So these are quite exotic because they provide an SPI or I2C interface for communication. So you need to instantiate an SPI or I2C protocol bus to communicate to these sensors. They also give you better accuracy, but they are very expensive. On the contrary, this provides a simple serial out interface using something like a one wire bus. It's not really one wire, it's a serial output, right? From there you can read it. And normally these particular DHT11 sensors come with 3 pins. There are some variants which I have seen which has 4 pins, but if you find a 4-pin sensor these days, I think one of them is a no connection pin. I should also tell you that the pin layout has changed extensively based on different manufacturers in the market. So who is manufacturing the board, right? So I've seen the sensor that I have here. The pin layout is like you have a positive data and you have negative. But I have seen sensors where these are swapped. Sometimes you find the negative first, data positive, sometimes positive, negative, and data. You get all kind of variants. I would recommend that when you buy it from the market, try and get the spec sheet specifically for that sensor to find out the pinouts. If you're lucky, you'll find the pin labels being written in here, like you can see on mine. I think if I zoom it, you can see this. Oh yeah, you can see it better. It very clearly is marked as positive, which is where you want to connect it to your VCC supply, which is 3.3 to 5 volt supply. This is the output pin where you can read the temperature. It's supposed to be connected to the GP pins of your Raspberry Pi Pico, and then the negative goes to the ground, right? So these are the layout. This is a pin layout on my sensor. If you have yours, you might have a possibility. There might possibility that these positive negative could be swapped out, or the data comes after positive negative. Just check it out, right? So if they have labels, they might be more useful. So I will tell you how to connect this to a Raspberry Pi Pico and read the temperature and display it on an LED display, which I showed in the previous video, which is the 7-segment LED display, a 4-digit 7-segment LED display, which is based on TM1637. So let's go ahead and first wire this up. Of course, in order to wire this, I'm going to use the same board which I had just used a while ago for creating another video where I try to connect this particular TM1637 sensor. Let me just try to reduce the zoom a bit so you can see it better. Sorry. Yeah. So I think I did a video just a while ago. I'll just show it on the card so you can have a look into it if you want to know how to wire this particular display up. So I have just connected this through the Raspberry Pi, and I have the sensor here. Even the sensor comes with this pinout, so you can use headers that look like this, right? The headers that look like this. you have a female header here and you have a male header here. So you can use this particular wire. So in this wire, you can see that I've found a wire that's got a white, gray, and a black color. So to make things easier for me to understand, I'm just going to use the white wire to the positive, connecting to the positive, and the black to negative, which is essentially ground. And the middle pin, I found a gray color, so that's what I could find this time. So I'm going to use that for data. So once you wire this up on the sensor, the next is this side. It's pretty obvious. So you can see that on the Raspberry Pi, just to remind, I have the positive supply connected to the pin 40 of Raspberry Pi Pico, which, let me just swap this across, show you. Turn the page across and show you. Yeah, you can see this. The V bus is connected to the positive and the ground is connected to negative rail. So I'm going to go ahead and use the white wire, which is actually connected to the positive of this particular sensor on to the positive of the breadboard. And I'm going to as well connect the negative to negative on the breadboard, like you can see here, right? So it's like you can see the positive, the white wire is connected to the positive and the black wire to the negative. And then this gray wire, I can connect to any GP pin of my choosing. You can connect to the first GP pin that you find here, or you can connect it to the next GP pins. You can connect use any of the GP pins that you find here. So I'm going to go ahead and use a GP pin that's the closest on this side. As from my previous video, I'd used these two GP pins, which is GP16 and GP17 for connecting to this LED display. So I'm going to use after the ground, you'll find GP18 is what I see here. So I'm going to connect that to the temperature sensor. So I'm going to leave one pin out and connect to GP18. So let me zoom this up a bit so you can see the pin layout better. Yeah, you can see it, right? So you can see this. So I just made a pin connection here, and this sensor is connected. Now, in order to access this, I'm just going to connect this to the micro USB. To my computer, of course. Let me reduce the zoom. All right, so I think my camera just got a little off, so I had to fix it. So anyways, so back again. So I've just connected this, as you can see here. All right, so let's move on to another scene where I will share the screen where I'll be using Tony. I have fired up Tony, and it seems like Tony is connected, as you can see here. So you can see that Tony is actually connected, and you can see the MicroPython prompt right here. So now you can access this particular sensor by using a library, which is the DHT11 library. In order to use DHT11 library, I think you don't have to install anything. I figured out that the default ROM that comes up with Raspberry Pi Pico, the MicroPython firmware, comes with DHT sensor library built in. So you don't have to install it from any site. So I could actually use the module as DHT. I can say from DHT, import DHT11. It works. No downloads, anything required. So this library is built in as part of your MicroPython firmware for, as part of my Raspberry Pi Pico. If you're using a DHT22 sensor like this one, like you see here, right? So use this sensor. This is sometimes labeled as AM2302. Okay, I think it's 2302 or 2303. I think it's 2302. So you find this sensor is very likely a DHT22 sensor. It generally comes up with a white, cap on top. That's one quick way to notice, and slightly bigger, right? And this sensor requires another library, which is DHT22. So the library is same, the module is same. You say from DHT, import DHT22 instead of DHT11. So I'm going to be using this sensor, which is the most commonly available sensor and also quite cheap to get in the market. So once I loaded this class, in order to access the sensor, it's pretty straightforward. You can actually use, I can just say sensor is equal to DHT11 off. You need to just specify the pin number which you're connected. Okay, I forgot to do this. I need to first type from machine import pin. And once you've done this, next step is you can instantiate the pin object based on the pin number I've connected. So based on the setting that I've done here, I think if I showed up the diagram, I have connected to GP18. So I've connected GP18. So GP16 and 17 is connected to the LED display. There's a ground pin, after which there's GP18. So I've connected that. So just look up your pin diagram and you'll know it. So use that number. So here I'll just type sensor is equal to DHT11 of pin 18. And now, in order to initialize the sensor and get some reading out, you might want to try sensor dot measure. And after this, you might want to try sensor dot temperature. This returns the temperature in Celsius, by the way. That's what I found. So if you want to convert to Fahrenheit, I guess you know the formula. You can just convert from centigrade to Fahrenheit and you get the answer. Or some of you might also want to use Kelvin. So you can also use Kelvin if you know the formula correctly, right? But this gives you temperature reading in Celsius. This particular sensor also provides humidity level. So in my room, I think the temperature is 24 degrees. I'm running an air conditioned room right now. So yeah, it's 24 degrees while I'm in Chennai, by the way. And if I try sensor.humidity, you get to know the humidity level. It shows humidity level is 57%. So this is how you read it. In fact, reading it this way is fine, but what if I want to display it on this LED? We'll write a small program to do that. So for this, I'll just fire up a new file. And in this file, I'm just going to go ahead and just type from machine import pin from DHT import DHT11. And I'm going to try from TM1637 import TM1637. Yeah, by the way, this is not built into the MicroPython standard library. So you need to download this from the GitHub URL. I have done a video on how to do that. Just if you skip that, just go ahead and look up that video. There will tell you how to get this particular module from the GitHub sources and test it out for this display, right? So that is already being done. So I'm going to save time in here. So I'm just going to use that module. That module is actually there in my RaspberryPi Pico. So I'm going to load that. And then the next step is I'm going to use a try block. Inside a try block, I'm just going to put a loop, which will periodically check the temperature. So I'll do a while true. And then, yeah, just remove that. First thing, I need to initialize the sensor. Let me first initialize the sensor and the display. I'll do that first. So I'll just try sensor is equal to TM1637 of pin 18. And my 7-segment LED display, the TM1637, is connected to pin number 16 and pin number 17. Pin number 16 is connected to DIO and pin number 17 is connected to the clock pin. So I'm going to use that configuration accordingly. So I'll just type display is equal to, oh, did I say TM1637 here? Big mistake. Sorry about this. So I have to type DHT11. Yeah, I might be a little absent-minded. Sorry about that. Yeah, so I'll say DHT11 of pin 18. Make the change there, okay? And display is equal to TM1637 of CLK is equal to 17 and DIO is equal to pin of 16. And once it's being done, within a while true loop, I will also import another module because I want to do this periodically with some delay, maybe every 2 seconds. So I'll just use from time import sleep. And here I'll just type sensor dot measure. You should note that the measure method must be called with a delay of 1 second at least on a DHT11. If you try to call sensor.measure within a short span of time, within 1 second, you might not get the sensor reading well. In some displays I've seen, sorry, some of the DHT11 sensors I've seen that you get a EIO error. Sometimes you get a timeout error, right? EIO error. So you might want to, once you call sensor.measure, at least have 1 second, this 1 second delay before you call sensor.measure another time. Okay, there's something to keep in mind. So you call sensor.measure, and after which you can just type temperature as a T. Okay, T is equal to sensor dot temperature. H is equal to sensor dot humidity. And now what I'll do is I'm just going to type display dot show. Now instead of telling dot show, if at all you want to display temperature, I would recommend using display dot number, right? Or display, oh no, display dot temperature, sorry. Display dot temperature of T. Maybe you can have a sleep of 1 second. Display dot show off. This time I want to show humidity with a number and a small h at the end, so I can use display dot show of curly braces. Let me use a format literal string. I'll just use the humidity value as 2-digit number, 0 to b, followed by, okay, I need to specify which particular variable, so I'll just use h here, h colon 0 to d, and I'll put a small h below. The h is the name of the variable. Maybe I should call it humidity to make it more readable. That's fine, I think. And this h will be displayed as is, right? Let me just close this. I'm going to put a sleep of 1 second. This runs in a loop, and this loop goes on until you hit the stop button or you press Ctrl C while you're running through Thorny. So you can handle that as an exception by using except keyboard interrupt, sorry. And you can just print. That's it. So I think it's done. So we can save this file onto the Raspberry Pi Pico. Under name, maybe we can just say, let's call this as show temperature. And now let me try running this program. Hopefully there's no errors. Yeah, it's working. The small bug that you see here though is that C is being displayed because it's the C is from the temperature, right? That's being displayed. If you don't want that to be displayed, maybe one small hack is that you could actually use a small space here. So that could solve it. Ideally, you should put a percentage. I don't think there's an easy way to put percentage on a 7-segment LED. If you know it, let me know. I don't know if there's an easy way to do it though. Maybe a degree, then a bar, and a small O might look like it, but I don't think there'll be enough display width for doing that. Anyway, so I think it should be fine. So let me say this again. Oh, it's busy right now, so I'll just click on stop. Don't want to click on stop. It says exiting and finally comes out. Now you can save it again. Okay, it's saved, right? Okay, it's saved. Now click on run. Maybe if you don't want it to flip every 1 second, maybe you can leave the temperature on for 5 seconds, then display humidity for 2 seconds, then sleep for 1 second. You can change the sleep intervals in here, and that you can customize the way you want. By the way, this is just a quick demonstration how you can use MicroPython to access a sensor and display it on an LED display, right? The next video will tell you how to create a small digital clock with a TM1637 sensor. I will also tell you how to use other displays like the 1602 or a 2004 LCD display, and also an OLED display through which we can display temperature, humidity, and other details. All right, hope you found this video useful. So if you do like this video, do press on the like button, and yeah, this way I think most people will appreciate, will know that it'll basically help the YouTube algorithm. All right, so thank you very much. So hope to meet you in the next one.